that, I made some funny graphics that I will show you in a minute. Because Juniter is mostly a backend, so not a visual tool. It's really just data transfers from one node to another. So there's nothing to see, but I wanted to see something, so I made a small interface. And after that, I was like, okay, let's do the protocol itself. So that means several things. So validating the documents, I will go into detail, and validating means two things. It means reading the document, so verifying the grammatical correctness, let's say, and after you verify that the document is correct, you can index it, so extract the information that you need and store it into a database in a way that you can reuse it and modify it. I mean, I'm going to. Finally, so after starting to code in Java, I was having discussions about the binarization and everything, and I come from, professionally, I come from some big data background, so I used to work with data systems that requires efficiency from many points of view. Meaning efficiency in reading, efficiency in updating the data, or just efficiency in the workload itself, or data transfer, or data storage. I mean, there's different ways to see efficiency. So this is what we call the OLAP type of tools. So for OLAP is for online analytical processing or something like that. That means that generally OLAP systems are oriented for read-only or for read-mostly data system, which is very fit to a blockchain, because we never modify the block, but we want to read what's inside several times. Okay, so reading the specs was kind of a long and boring process. So it's well written, and most of it is written in the specification. There's just some tiny problems, but it's globally it's fine. We can understand the protocol and we can implement it, which is something I think was important, because the Juniter is a protocol, is more than just one tool, especially if there is more implementation coming, and the Rust implementation, or the Java, perhaps one day a Python implementation as well, if some developers want to push a little bit. So the specs is composed of three big pieces. The local validation that describes the document, as I mentioned. So we verify the grammatical correctness. The global validation, which is the indexing, that when we extract the data and in order to use it, to verify, for instance, the transaction, or if somebody is a member, or if his membership was revoked, or whatever. So this is the database, if you wish, of the blockchain. And then there's a network layer that has more than one implementation, the BMA that you all know, the WebSocket that you all know, and the GraphQL as well. Perhaps one day a binary a binary protocol to compress a bit more the documents. So for the implementation, I chose because I'm coming from the Java world, so I use mostly tools in Java, and so when I started this implementation, I chose to use Spring Boot, which is a framework that is gluing things together. That's really really convenient to make a big application, let's say. Not having to code everything by hand. There's a lot of libraries and so on. So for the local validation, I use the grammar. So that's the important part because the grammatical validation. Okay, I see a message. Okay, the grammar is of the protocol is what is common, which is independent from the implementation. So whether this is the Rust or the JavaScript or Java or Python implementation, then we all have to respect this this formal document description. And so that's why I got the idea after discussing with Cedric that perhaps the grammar was a good way to formalize the protocol itself, because we can do machine validation of the protocol if we push a little bit further. That means, for instance, if one day we want to evolve the protocol or something, then we can independently from the implementation themselves, we can verify that the protocol is consistent. So for those who don't know, a grammar is composed of, a formal grammar is usually composed of two things, a lexer and a parser. A lexer looks like that. So that's the lexer tells you what kind of tokens, what kind of things you're going to find in your language. Basically, it's your dictionary that describes every token that you can find. So that's not the most interesting part. The interesting part is more the parser itself. So that describes the rule of how to place the words together. So, that if you make the analogy to natural languages, that would be the grammar of the language. So for instance, if we take, to make it simple, we take a blog is composed of a version, a doc type blog, which followed by currency, followed by number, pole, mean, time, median time, blah, blah, blah. And this way we can describe the entire, all the documents and have a formal version. Why did I do that? Why did I not use native Java to do it, and I rather use the Antela system? Is because the local validation, so the grammatical validation, can be completely externalized from the rest, from the state machine itself. So we can entirely proxy the execution of the local validation. So for instance, if you imagine a system where you have one state machine and you have multiple front ends, you can filter correct document on the front ends or on the fronts, rather than doing it on the same machine that is going to do the heavy work. So you can really externalize that. So I had to code it in a way that can be completely externalized from the rest of the implementation. And using antenna, I have this benefit from yes, I have the benefit from generating this the parser. It generates a parser in several languages. Wait a minute, I will find it's here. So I can generate the parser for 1, 2, 3, 4, 5, 6 different languages. So okay, let me summarize that. So we start with the okay. Is it better? So what we code inside the grammar, like here, gets converted into code that looks like. Give me 1 second. That looks like source. No. Sorry. Here we go. No. Damn it. I don't find it. No. Okay, never mind. I will go into the code later and I will show you. So, but we specify the grammar, which then is compiled into native code, into native binary code to parse and validate the document in an efficient way. Finally, for the technology part, I took Gradle. So if you people know Maven, it's a bit old, and I wanted to use another tool. The index for the after you validate the document themselves, you want to index them. So either you validate new documents. So that means, for instance, someone wants to make a transaction or someone wants to register its identity. So you're going to have a small identity document which you want to add into a block, or you can receive a block, or you can receive a transaction or anything. But once if you receive a block, you want to index the data that was inside the block, inside your own database, the local database. And the indexing process means that's how I view it. It means 3 things. It means that we denormalize the content, the data content. We denormalize it in a way that we can query it very easily, very efficiently. So basically, we want to have a single array, a single search. We don't want to make join queries every time there is a new document, because that would take too much time. So it's a trade-off between do we have more space, or do we want to have more a faster execution, faster verification. So for now, I'm mostly indexing in the same way, in the very same way that Juniter is coded with, because encore un peu, okay. Okay, I cannot zoom the presentation then. So we can index we index every document. Typically, we are going to index the transaction into a single big array, and then search for it. And the last part of indexing, which is the most important, and I haven't implemented that part yet, but the point of indexing is also to be able to handle forks. That means add data onto a stack or onto an array and remove them. Because when there is a fork happening and we have to change a branch, then there will be a need for changing the index itself. Like a transaction may be valid into one fork, but not into the other. Okay, so to 2 years ago, I was looking for something a bit different, and then I don't really appreciate dogmas, and I really encourage polytheisms because I think they are more alive. The stories are more lively. So, for instance, if you know the story of Medusa, it's more complex than what it just looks. And yes, so I started looking for a Medusa, and what I found was Juniter a few months later. So why anarchy? What's entropy? What's the demos of user, and what's anarchy here? If I take the definition of Immanuel Kant, given by Wikipedia, there's different way of there's different organizations, social organizations to coordinate people, and the problem of consensus very much relates to how do we organize it together as a group. So historically, there is many form of organizations, and we can see the evolution. So the definition that Kant gives is very interesting to me, because we can distinguish three main three vectors that looks compatible as a pair, but are incompatible altogether. So the three of them doesn't seem to be very compatible. So for the analogy, anarchy doesn't seem to be a possible way of doing things, but yet we keep on searching for it, and searching for it is what's interesting. Let's continue. So, from a technological point of view, and this is so I'm going to present my view on how the tool should evolve, and what is my orientation. So first, we had a Turing machine that could do one thing at a time, and then we were like, okay, but that's nice to have my mouse pointer moving as the computer is computing something. So we invented multitasking, and then when multitasking came, we were like, okay, great, now we can have more than one core, and we can parallelize things. But then if you look at how the industry works, very quickly you realize that even parallelism is not enough. Like, you have terabytes of data and you want to have the answer to your question in a few milliseconds, then you can't use parallelism. It's not enough. One processor is rarely enough to do the entire job. And so if I take an analogy, for now you can compute using the Raspberry Pi. You can use Juniter on the Raspberry Pi, but once there will be terabytes of data, that the Raspberry Pi is not going to be able to answer your questions. However, if you use 10 or 100 Raspberry Pi, perhaps it's possible. And distributed system is where I come from, and where I think I'm trying to take my implementation of Juniter itself. So that means making it works on a multi-machine system. The use cases inside the industry is because they want to have systems that never goes offline. that's always up, and that even if there is a failure of one machine, then the system continues. But we can also apply that for fast execution, for faster execution. So in the distribution problem has a hiccup. There is no solution. There is no perfect solution to the problem of distribution because of this theorem that is really nasty. So it says that you cannot have all the three vectors at the same time. You cannot have full consistency, full availability, and full partition tolerance. So typically inside a blockchain, we don't have that issue because we are only working with consistency and availability. We don't really partition the data. We replicate it a million times or like 1,000 times, which is pretty inefficient, but we don't apply. But so I'm showing you that because it's important to when you design a distributed system to understand what context you're working with. And here we clearly on the CNA area, the blue area. And there is one thing that this theorem tells us is that the point in the middle does not exist. So you see it here, but it does not exist. And if you, so I really want to make this analogy, even if it's really bad. But remember, a few minutes ago, I mentioned a problem that has three vectors compatible as pairs, but not all together. And we have a very similar problem here. So how do we organize each other in a distributed environment is a problem that we mathematize as in IT engineering, but that's a problem that philosophy is also trying to solve for quite some time. And to me, I see a very clear analogy. Perhaps it's not that clear, but I like it. And don't worry, so that's the engineer sort of diagram, but there's also one version for nerds, for theoreticians. So like this is the white paper, 2PC, Paxos, and Blue Acids are the white papers, and this is like if you are like practical approach and you want to really implement something that, but that's the same diagram. Okay, so okay, that's just a presentation for a generic presentation. So that's how it works simply. So what I mentioned earlier, you receive a document that can be a blog, identity, transaction, or whatever. You verify it, so you send it to a teacher. The teacher can be externalized, which I mentioned. And once the teacher has done the job of correcting or at least verifying that the X, Y, and Z are correct, then you extract the X, Y, and Z and you store them into a database, which then allows you to create a block or add the block and add the block at the top of the chain. So typically, if we have this input identity document, we are going to have this line added inside the block at the end. So that's it for the presentation, but I wanted to show you some code. If I can maybe share or something else then. Where is the screen sharing? Yes. Okay. So when I mentioned earlier the grammar works like you code something. You code something like this. You code your tokens and the parser, so all the rules, and what you get in return is in one of the 6 languages that you start with, that you compiled for, sorry. So JavaScript, Java, C++, C#, or Python. And then what you get is this. So it's an ugly generated code, but it is, if you, it contains all the token, it contains all the code, and most importantly, it binarizes the parser, which means that when it executes the parsing of the document, it does it at the binary level. So in this way, no matter what's the input, JSON, text, binary, this is very generic way of reading input data. It's a bit more annoying and a bit longer to code. So the closer you get to theory, the more tricky it becomes. But it's generic, and I can theoretically parse any non-ambiguous data. Okay, so about the project itself, so you can see it running here. There's a lot of mistakes, there's a lot of errors. It's really incomplete. It's not finished, and there is still a lot of bugs, but it kind of works a little. So there is one interface, one like native interface. Well, it's a bit crappy, like the graphic. I'm not a graphist, and I really didn't spend time on it, but it's just like an admin panel so far. What's interesting is this. So after at the beginning, after I finished mirroring the blockchain, I started to play a little bit with it and try to represent the blockchain graphically, and I came up with that. So this is Dot language. I don't know if some of you know it. So it's a text document that generates this graph. So you generate the text document that generates this, and you get PNG or SVG results, which is pretty awesome because SVG you can manipulate the way you want. So what we can see, so we can click, but what's interesting, for instance, if I take this block, is that we can navigate. We can navigate along the transactions. Okay, it's really ugly, and there's still a lot of little bugs, but what you can see is okay. You don't see. Yes, I have to share the screen of. Okay, one second. Select window. Yes. Okay. Sorry. So I show you the main panel, right? Which I said was an ugly interface. What's interesting is the graph part, where we can visualize the blockchain itself. And okay, so the point was, if I take a block with a transaction, I can go and click and see the transaction happening. And okay, it really looks bad right now. It's not finished, but the idea is that we could monitor what's happening and how the the state machine works and how every piece is inside the core is being shared. So, for instance, we see that the universal dividend ends up being used as a transaction, is signed, blah, blah, blah. There's a total made, and then we get output, and the output is split in two parts. One part comes back to the issuer, and the other part is what's transferred, because it's like working with checks. Imagine that there's no coin, no banknotes, no nothing, just checks. And you take a check, you delete it, you collect a lot of checks, and then you make a new one out of it. So I imagine this interface to be like some sort of monitor, because graphically it's limited, at least natively, but it's SVG, so we can perhaps template it a little more. But so I had two visions, let's say, for this interface. One is one is like really like a monitor, and the other one would be perhaps some tutorial or someone who wants to understand a bit more technically how it works, that we can represent it graphically. We can have colors and say, okay, this transaction is wrong because this, and have it graphically explained, not just some weird text messages. Okay, I think I've done. I presented everything. Do you have any questions?
Moi j'aurais limite qui retombe sur le 4x4.
Maybe I should open the chat.
Ah mais non.
Wait
for the questions. On parle du 4x4. Le 4x4. Ouais, il parlait de constancy, règlement et partition tolérance. Ça va un peu ce que c'est.
Hi.
Hi. En français, c'est possible?
Ah, moi en français,
What's the state of the project? I think there might be a beta version at the next meeting in 6 months, but I don't know. I can't guarantee that, because now I've coded most of like all the structure. What I have is mostly, so I have coded a bit of everything. I've done all the annoying part, basically all the integration, finding the right libraries and everything. But then I have to glue every pieces together, and that's usually the tricky part. So this is the moment where the code can take 6 months for for almost no visible progress, and it can also go very fast. So I prefer not to make any promises, but I think that there might be some beta version in the next meeting. Les trois incompatibilités. Ok, so, alors, en français. So if I come back up, okay, si je reviens à la présentation, ok. Ok, so, ok, le problème de la, je dois partager l'écran,
On va le raser.
Qui a une question, je peux l'écrire.
Oui, t'as une question?
Non, qui a une question, je peux l'écrire pour lui. Oui, pour une autre pour la suite.
Ok, so le problème de il y a trois éléments, il y a trois vecteurs en fait qui sont incompatibles tous les trois ensemble. Il y a la consistance. Donc la consistance, on va dire, c'est l'aspect purement logique. Est-ce que ma valeur elle est vraie ou fausse à un instant donné? Est-ce que ma valeur de x c'est x ou x plus 1? Est-ce que voilà. Donc c'est d'un point de vue logique. Donc en général, ce qui va concerner la consistance, c'est là où on va retrouver l'aspect très matheux, théorème et logique. Ensuite, les deux autres, moi la manière dont je vois ça, c'est que les deux autres parties vont plutôt d'un point de vue technique. Qu'est-ce qu'on veut? Availability, c'est la disponibilité du service, ça veut dire la disponibilité sur plusieurs points de vue. Donc ça veut dire la disponibilité en lecture, la disponibilité en écriture, la disponibilité par exemple dans un système de transaction. Est-ce que le système va me permettre de consulter mon compte? Est-ce que le système va me permettre de faire une transaction? Et donc, ce problème-là, il va venir un peu en conflit avec la partition tolerance. Donc là, est-ce que je peux fragmenter mes données? Est-ce que je peux faire du sharding? Peut-être certains, ça parle à certains le mot. C'est-à-dire, est-ce que je peux couper mes données? Donc typiquement un sharding, ça va être au niveau d'un état par exemple, on va diviser en villes et donc on va organiser les choses dans les municipalités plutôt que de les organiser au niveau de l'État, parce qu'il n'y a pas de sens à le faire au niveau de l'État. Sauf que alors on peut voir, on peut simplifier, hein. On peut s'imaginer que si je dois faire une transaction avec mon voisin, c'est facile de partitionner, c'est-à-dire qu'on pourrait partitionner par ville, et dans ces cas-là, faire la transaction avec le voisin, ça demande à deux personnes d'aller à la mairie et point barre. Le problème, c'est que quand on partitionne par ville, si j'ai envie de faire une transaction avec quelqu'un qui est à l'autre bout du monde, et il va y avoir un autre problème. Il va falloir que ma partition aille demander à l'autre partition est-ce que j'ai le droit de prendre l'argent, de l'emmener sur l'autre compte. Et donc la disponibilité et la tolérance à la partition sont deux vecteurs qui on voit assez facilement que ça va vite y avoir des problèmes. Et donc si on ne partitionne pas, on va se retrouver comme dans une blockchain, dans le cas de la blockchain, on ne partitionne pas du tout. Donc on réplique. Donc toutes les données en fait sont répliquées sur tous les nœuds. Et donc c'est d'un point de vue données et d'un point de vue énergétique, c'est pas tant que ça, mais c'est surtout d'un point de vue stockage, c'est pas ce qui est le plus efficace. On réplique des dizaines, des centaines, voire des milliers de fois la même donnée. Alors ça offre la garantie que la donnée elle soit bien ça donne de la fiabilité à la donnée, mais c'est pas très efficace d'un point de vue purement machine. On pourrait faire plus simple, mais après voilà, et ça apporte d'autres risques. Donc ces trois vecteurs là, donc pareil avec la consistance, est-ce que je peux partitionner mes données? Donc c'est l'exemple que je citais plus tôt. Comment je fais pour faire une transaction si j'ai un compte à Lyon et un compte à Marseille et que je suis divisé par ville? Voilà, je vais avoir un petit problème. Voilà. La disponibilité, c'est surtout la charge que c'est capable de supporter, c'est-à-dire plus pour une blockchain, ça il n'y a pas vraiment de problème, parce que plus le réseau est gros, plus il y a de nœuds qui seront capables de répondre aux questions. Et donc, voilà. Donc nous on se trouve vraiment dans la zone C. Hein. Pourquoi avoir développé une nouvelle implémentation de Juniter? Quelle a été ta motivation? Alors là, pourquoi avoir développé une nouvelle version de Juniter? Pourquoi? Parce que j'ai un esprit assez chaotique, et quand je dis chaotique, c'est j'envisage pas le chaos comme quelque chose de dominant, mais comme un élément essentiel. Si par exemple, je sais pas, peut-être que parmi vous, il y a des gens qui ont fait du machine learning, c'est ce qu'on appelle l'overfit, quand on essaie de chercher, d'avoir la réponse absolue à une question qui n'est pas d'ordre logique, qui est d'ordre, on va dire, statistique. On peut approcher une réponse, mais on ne peut pas vraiment l'avoir. Quand on cherche à apprendre à la machine de manière exacte à reconnaître un chat, elle va donner des réponses complètement absurdes. Et donc, au bout d'un moment, quand l'algo devient trop performant, il dérive vite en fait. Il peut devenir fou. Et donc le chaos dans tout ça, c'est-à-dire on va injecter des données fausses, et ça va empêcher l'algorithme de converger vers l'absurde. Et donc typiquement une blockchain, c'est un exemple où le chaos est très utile, parce que en empêchant une certaine convergence, on garantit la fiabilité du système. Et donc, en fait, pour moi, réécrire Juniter en Java, c'est un peu comme écrire une biographie, quoi. Est-ce qu'il y a une autre question?
C'est bon. Trop bonheur de l'envoyer maintenant.
A revu la partie BDD pour permettre une synchro plus rapide. Ok, alors je sais pas exactement quels sont les changements que Cédric a opérés sur son code. Par contre, pour l'instant, moi, l'indexation est faite uniquement en RAM. C'est du code pur Java, il n'y a même pas de base de données qui est associée, parce que justement je mentionnais les systèmes OLAP, et je n'ai pas l'intention en fait de garder l'indexation ni dans une base de données ni en RAM. J'ai l'intention de l'écrire à terme dans ce qu'on appelle les systèmes big data, parce que je pense que c'est bien plus adapté pour faire des grosses requêtes. Pour l'instant, alors je télécharge la blockchain et je vérifie les documents, donc la signature, les hash des documents. Ça me prend 10 minutes. Après j'ai un ordi avec 4 cœurs. Sur un petit serveur OVH, ça me prend genre dans les 35-40 minutes. Maintenant, j'applique pas encore l'indexation, donc je pense que ça prendra un peu plus de temps. Et puis, bon, pour l'instant, le code n'est pas vraiment terminé. Alors, pour quel type de machine je cible pour Juniter, ça dépend, parce que Juniter, en fait, c'est plein de modules Spring, on va dire. Donc, ça dépend si on l'allume en mode j'ai envie de répliquer la blockchain localement. On peut juste l'allumer.
Passer au compte suivant, c'est ça?
Ouais, c'est ça.
On lui dit c'est fini? On lui dit c'est fini?
Si vous voulez, ouais.
Bon, le son a coupé.
Alors, moi, ce qu'on est en train de dire, peut-être.
Remets la cam, ce qu'il te voit. Au moins qu'on l'applaudisse, quoi.
Ouais, le son a coupé, voilà, on t'applaudit, on va couper le flux. Hein. Ouais, d'accord?
Voilà. On va laisser payer.
Super. Merci.